So, welcome back to Spacer. Today we are gonna be talking about the black hole, the myth about what really is it, and a lot more things, so let's start. I know that most of the people are known to what black hole exactly is, but for those who don't know, a black hole is a region of space-time where gravity is so strong that nothing, including light or other electromagnetic waves, has enough energy to escape it. The theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole. The boundary of no escape is called the event horizon. Although it has a great effect on the fate and circumstances of an object crossing it, it has no locally detectable features according to general relativity. So today we are going to be solving a myth about the black hole. Most of the people only think that black hole is a substance which has a strong gravitational force and pulls everything which comes near it. So is this definition right? The answer is clearly no. Most of the people only think about what they see. Most of us have seen the black hole as a ring-like structure, right? But will we judge the ability and strength of it only by its shape? Of course no. In this video you will know what the black hole really is. So let's start. What is a black hole? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape its gravitational pull. They are formed from the remnants of massive stars that have exhausted their nuclear fuel and undergone a gravitational collapse. When a star collapses under its own gravity, it forms an extremely dense object with a tremendous gravitational force. This concentration of mass in a small volume creates a gravitational field so intense that it creates an event horizon, a boundary beyond which nothing can escape. Black holes have three main components: the singularity, the event horizon, and the accretion disk. The singularity is a point of infinite density at the center of a black hole where the laws of physics, as currently understood, break down. The event horizon is the boundary surrounding the singularity, beyond which the gravitational pull becomes so strong that nothing can escape, not even light. The accretion disk is a swirling disk of matter that forms around the black hole as it pulls in surrounding material. Black holes come in different sizes. Stellar mass black holes are typically a few times more massive than our Sun, while supermassive black holes can be millions or even billions of times more massive. They are found at the centers of galaxies, including our own Milky Way. Black holes continue to be an area of active research, and studying them helps us understand the fundamental nature of gravity, space, and time in extreme conditions. Myth: black holes are cosmic vacuum cleaners that can swallow everything in the universe. Fact: black holes have a strong gravitational pull, but they do not suck everything indiscriminately. Their gravitational attraction affects objects that come within their event horizon, which is the point of no return. Anything crossing this boundary will fall into the black hole, but objects outside the event horizon can still maintain stable orbits or move away. Myth: black holes are portals to other universes or dimensions. Fact: while black holes are fascinating objects, they do not serve as gateways to other universes or dimensions. They are formed from the collapse of massive stars and are bound by the laws of physics within our universe. While they can distort space-time, there is no evidence to support the idea that they connect to other realms. Myth: black holes emit an infinite amount of light. Fact: black holes themselves do not emit light. The term black hole refers to their ability to absorb all light that enters their event horizon, making them appear black. However, the matter surrounding a black hole can emit intense radiation and form an accretion disk, which releases vast amounts of energy before being consumed by the black hole. Myth: black holes are always growing in size. Fact: black holes can grow in size by accreting matter from their surroundings. However, they can also lose mass through a process known as Hawking radiation. According to Stephen Hawking's theory, black holes gradually emit particles over time, causing them to slowly lose mass and eventually evaporate. This process is extremely slow, especially for stellar mass black holes. Myth: getting too close to a black hole will result in being stretched into a long, thin shape, spaghettification. Fact: spaghettification is a real phenomenon that occurs near black holes, but it is not as instantaneous or dramatic as often depicted in popular culture. As an object approaches a black hole, the difference in gravitational pull between its head and feet can cause it to stretch. However, the actual process would likely be fatal before reaching an extreme state, and it is primarily relevant for objects falling into supermassive black holes. So I hope now you can understand all the myths and facts about this, so make sure you have a good knowledge about it. See you soon. Goodbye.